Find the critical t-value that corresponds to 99% confidence with n equals 10. So once again, 99% confidence is the middle area. And for t-value, we use the t calculator. So let's do it again. Stats, calculator, t. In between and middle area was 99%, so 0.99. And now in the previous problem, they were giving us the degrees of freedom. And now for the first time, they don't give us the degrees of freedom, but they give us n. N is the sample size. So degrees of freedom, as I remarked earlier, is one less than the sample size. In fact, let's write it down. So degrees of freedom is equal to sample size minus 1. So n is always used for sample size in this course. So degrees of freedom is sample size minus 1. Okay. So if n is 10, then degrees of freedom would be 9. Let's change this to 9. So negative 3.25 and positive 3.25. And if they just ask for the positive one, if for one of them, then you take the positive one. Given the same sample statistics, which level of confidence would produce the widest confidence interval? So we talked about this in the previous section, that the more the confidence, the wider the interval. And so to get the widest confidence interval, which level of confidence would give the widest? So the highest level of confidence would give the widest confidence interval. What's the point estimate of a population parameter? So a point estimate, okay, and then they say given a simple random sample from some population, such as population of all basketball players in the NBA, how would you find the best point estimate of the population mean? So point estimate is a single value, and that's based on the sample. So let's say here the population is basketball players, all the basketball players in NBA. So you will take a sample of those players instead of taking all the players, and then determine whatever you are finding. Let's say you are finding their heights. So instead of taking all the NBA players, you will take, let's say, 50 of them and find their average height. And then that average height will serve as a point estimate. So point estimate is a single value. Now it's based on the sample, but if you don't know anything else about the whole population, then that sample value is the best estimate for the sample, for the population. So for example, if you find the heights of those 50 NBA sample players that you took, let's say you find their average height to be 6 feet 2 inches. Now, you don't know what the average height of all the NBA players is, but based on what you have for the small sample, you can say that that is a good estimate for the whole population in the absence of any other knowledge. Of course, it's not necessarily equal to the population value, but that's the best you can do. So point estimate is a single value used to estimate a population parameter. That is true in all the four. So let's look at the second part. The best point estimate of the population mean is the sample mid-range. No, the best point estimate of the population mean is the sample mean. So means should estimate means and nothing else. Population mean, the best point estimate of the population mean is the sample mean. So that's the one.